What's your goal with the podcast? What are you hoping to achieve with the entirety of this podcast? You're
Yeah,
exploring,
that's a great question.
yeah,
It's an applied professionals applied AI podcast. So the intention is that we focus on people kind of at our mid range in a company and how it's actually being executed and deployed in companies. And then I like to sort of go back and forth between philosophical questions and then down into more into the weeds and how people are actually deploying it. And the
sure.
benefit there is I think it presents a picture that's not just hype based. It's a picture that shows, the actual ramifications of decisions related to AI at companies. If you listen to a typical podcast, you're hearing people who have been vetted by PR and they're heading AI companies and stand to lose a lot of money, or they have some specific message that they're trying to get across versus someone who's actually just deploying it and witnessing it evolve in a practical sense. Welcome to Smolder, the Professionals Applied AI podcast. I'm your host, James Wagenheim, and today's guest, John Draper, is a CAM automation software developer with Hexagon. He is a talented machinist with deep experience in computational geometry and precision manufacturing, and a close personal friend of mine. Automation has been the cornerstone of manufacturing since the Industrial Revolution, and in today's discussion, John and I will explore how AI, the successor to early robotics and automation, is showing up and what the future might hold. And if you like this conversation, please hit the like button, subscribe, or find us on Patreon. Without further ado, here is John Draper. John Draper, welcome to the Smolder podcast. Thanks for being here. John and I have been friends for a really long time, and I'm really excited to bring him in so that you guys can hear his experience in software, but also in manufacturing. And welcome, John.
James, thanks for having me. I'm looking forward to this. It's a really exciting opportunity, and I should probably tell everyone, James and I have known each other for 30 years. He's one of my brother's best friends growing up and was always working on computers. And I remember one time James took apart our family computer in our living room and put it back together. And I think there were about 10 to 20 screws sitting in a little bag next to the computer. He's like, "Oh yeah, we don't really need all those screws. It's good as it is."
Yeah,
So
I stand by that.
yeah,
Also, that was not one time. I feel like I was taking that computer apart once a week because
yeah,
something wrong with it.
yeah, absolutely. It was a desktop Dell, probably in like the late 90s. Yeah.
Yeah,
Anyway, it was always a lot of fun getting to know you as a kid and seeing your career develop as a software engineer. So really
awesome.
inspired me to move into a technical field.
No
So
way.
absolutely, yeah. I'm excited to go into detail about some of the precision engineering concepts and some of the methodologies people are using with AI. And
Well, why don't we just dive right in and start with, how you've seen AI start to show up and feel free to give some of the background in manufacturing and precision tooling.
yeah, sure. So my personal background, I started working in machine shops 10 years ago. I have experience working in a quality clinic, setting up CNC lathes, setting up CNC mills, programming lathes, running lathe departments, programming 5-axis mills, programming mill turn machines. I've probably programmed about 40 different machines over the last 10 years and over 100 to
So cool.
200 parts. So, and as a part of working manufacturing processes, I've also gotten to redesign engineering workflows, digital workflows, set up machine data collection systems in machine shops to pick up real-time data off of the CNC machines. I've set up tool database management systems for maintaining tooling, worked with real-time, systems, designing systems for CNC machines to improve the productivity of the machines, and then
Sure.
a lot for lights out machining and unmanned machining and stuff like that. And then I've done a lot of process optimization projects
Mm.
where, we take a existing process and we try to cut the cycle time down to like 50% of the original cycle time is always a good goal. That saves about one machine a year. I've done that
Oh,
about,
wow.
6 times over the last 10 years.
Well, let me
So,
just ask a quick question
yeah.
because I'm a little naive in this category. What would you call cycle time? What does that mean?
Yeah, so a cycle time is, production machining is all about saving time, right? So if you
Yeah.
can if you can take a process and take the cycle of the process, a part takes 10 minutes, and you can make this exact same part in 5 minutes,
Yeah.
you've doubled the productivity of that cell, and that machine can now do twice as much work in the same amount of time. So
And that I'm just sort of spinning on what you were saying or what I thought you were saying. That also leads to not just greater efficiency, but a longer term function of that machine. Is that what you're referring to, or?
yeah, so more specifically, product output,
Okay,
and
just output.
without
Okay,
hindering the machine itself.
I see.
Yeah, a lot of times, and saving process time, depending on how you go about it, you don't have to increase cutting forces or anything like that. You can often save time on processes just by rethinking the process itself, redesigning the application of toolpath to a part, just changing the toolpath enough to be able to save time on it. Those sorts of workflows take time because you have to, reprogram the part throughout the CAM environment. So
Mm.
so there are all these exciting things that I've had the opportunity to work on throughout the last 10 years. Industry wise, the industry in the last 10 years, what I've seen and the focus, it's evolving fast. I mean, 10 years ago, the tool database management systems like TDM systems and TMS Zoller were really taking off. Really better integration of CAM systems and better post processing, and really a high focus on post processing. 5-axis machining was really adapting. YouTube was happening. The precision machining industry's really been a industry that's doesn't have a huge amount of publication
Mm-hmm.
on the physics and stuff around cutting paths. So seeing YouTube and seeing these great YouTubers like Titans and NYC, and then
Mm-hmm.
going on the blogs like Practical Machinist and stuff, it's a Reddit, and what these other parts of the industry have really done to evolve the entirety of precision machining has been really
Yeah,
cool.
that's interesting. I feel like software has had such a strong online community of sharing information and building on people's skills. And it sounds like that's something that's new in your industry a little bit, but it's starting to take off.
Absolutely. Yeah, it's really taking off. One of the things about the industry is a lot of times these experts in the field are application engineers. I've worked with tooling companies or machines, and or people moving around between facilities. And now
Yeah.
now there's a lot of videos online showing tools cutting, showing how to apply these tools, and how to really gain efficiency. There's a lot of focus in that area. It's really amazing. The online community is awesome for it.
So, just a quick anecdote. My late father, he worked in, I guess it was just a woodworking shop for a little while, and he was struggling to work through their and set up their CNC machine, their CNC router. And so he was working with G codes, which is sort of the underlying tool paths, I guess, for lack of a better description. And I got to spend a little bit of time playing with that and helping getting him up and running. And so that was a cool little window into manufacturing. That turned on a couple of lights in terms of how I understand things to be manufactured in an automated way. And so he went on to work for a publishing company where he actually cut out covers and books and bindings and those kinds of things. And it was all sort of using the similar technology of tool pathing. And it's cool to see how tool pathing has evolved, and it's pretty remarkable, but you can definitely see the early foundations there.
Absolutely, yeah. In my current role, I work with Hexagon Manufacturing. I'm an application engineer for Spree, and it's a CAM company, so they computer aided manufacturing. The idea is that you can bring in a CAD model from an engineering design,
Mm-hmm.
and then program and create the toolpath. And the amount of algorithms and time and the amount of energy that's gone into generating CAM, and the types of toolpaths that are created are just unbelievable. From just standard pocketing and standard operations drilling and kind of straightforward things, to these dynamic milling where you're generating millions of lines of code.
Yeah.
These CAM systems are 5-axis machining, millions of lines of code. It's amazing. In my career, I've probably made 1 billion or more lines of code from programming in CAM. So it's kind of it's a very, very cool thing, and getting those numbers right is critical. I mean, if you think about it, if you have 3 million to 5 million lines of code in a machine and one number's off by enough, you can
Hmm.
break a, $400,000 CNC machine
Yeah.
or, $50,000 CNC machine. These mistakes are critical, and getting these numbers right and making sure that the software is making precision is important. But I knew your
So
dad. I did know your dad was was a CNC programmer at one point, and he was always really hands on. He rebuilt your whole house. Really funny.
definitely.
Really great guy. Oh yeah, I was gonna say it's funny we're talking about AI. You and I, it's full circle because your dad was the first guy to introduce the Matrix movie to me whenever I was a kid.
Yeah.
Just kidding.
Now we're watching it all unfold. Well, that's actually a good segue because I'm curious. As you mentioned precision, you mentioned documentation, you mentioned a couple of things that I could see where AI would find good applications at all of those spaces, including you and I have talked about this in the past in that, we have pretty robust algorithms that we can execute to create really optimal tool paths. And then, of course, there's space for AI along all those verticals. What are some of the different ways that you would say AI is starting to creep in manufacturing that you're paying attention to, and I guess some of those verticals, but also the different types of AI that you're seeing? Because I imagine
Yes,
there's multiple ways to apply those.
there's so many right now. It's a hot topic, right? But I think one of the things to think about is like where we were, like I was saying 10 years ago, and how AI fits into the fold. But definitely what we saw in 10 years is all this development of sensors and automation, bringing in robots
Hmm.
and design hard coding workflows. And we saw a huge amount of improvement. So, one of the areas that we saw some great software was, tool database management systems, organizing your tool data and building in pool systems for maintaining inventory levels, utilizing the ERP system the predictive analysis of when a job's coming, making sure that the tools are getting ordered ahead of time so that the job can run correctly. So software is used for that, utilizing
So,
AI in these workflows, and sometimes there are systems that rebuild the entire schedule for a workday for a week and can
mm,
predict when the machine availability is, and this stuff has been happening for 10 years, but
wow.
it's a great these are great systems for functional machine learning.
Well,
Uh,
let me pause you there for a second to make sure I
yeah.
understand and digest a little bit of what you're saying. That basically what I'm hearing is sort of an end-to-end approach has had really robust algorithms in place, and you've been tuning all the way down to when are we ordering parts? Do we have what we need to make the actual end
Yeah.
product? And do we have the people that we need? Is it that sophisticated, sort of end to end
It,
already?
it is, yeah,
Yeah,
with these ERP systems and not for every company, obviously,
sure, but it's there.
but it's there. It's something that can be connected and put together.
Yeah.
Sometimes it's an expensive solution. Sometimes it's a less expensive. There are people designing their own systems to do this sort of thing, and it's a really interesting that part of it's a really interesting field. Another type of system that's in use that I got to use is spindle load monitoring systems. While the machine is cutting, keeping track of the loads on the machine. If the machine starts running into too heavy of a load, the machine will stop. Or if it's going too light of a load, it'll speed up the machine.
Mm.
And then also from the same company, there's this company called Karen Engineering. They created a way for plugging a CNC machine to a CMM, a measuring device, and then having a feedback loop for autonomous machining so that the machine can operate on its own without an operator measuring the parts and making micro adjustments. Because
Mm.
in the world of machining, you're holding 1/1000th, a tenth of tolerance. Really importantly, in addition to the AI, is you can't take precision out of the equation. Precision always has to be there. That's the point
Yeah.
of precision engineering. Maintaining precision, maintaining these tolerances, keeping the machines calibrated, and
And
building in these quality systems for that.
going
But
back to the first point you made. So when you were talking about the tooling being under load, that's sort of like monitoring how effective your tools are making cuts, or your systems are checking like how effective are my tools cutting? Are they optimally operating and producing the most efficient parts, blah, blah, blah. Like, is that kind of the idea?
Well, it optimizes time. That's one thing. Another thing is it keeps track of load deviations. If you think about the physics of cutting something, if you're using a dull knife to cut a
Right.
potato, it's going to be a little bit harder, or
Yeah.
tomato, than if you're using a sharp knife. And the same thing happens in CNC machining. If you're using a dull blade to cut the metal, the machine's going to start reacting, and the metal that's used to cut metal is oftentimes tungsten carbide or
Hmm.
ceramics or high-speed steel. And these metals, they can wear, the tool can dull, and then they can also shatter, right? So the
Yeah.
entire tool can explode, and you're basically welding metal together at that point. These sort of spindle load systems really keep track of those metrics just to make
Yeah.
sure that the machine's not going to crash. Machines have built-in sensors for this, but
Sure.
whenever dealing with fine-tuned cutting operations, let's say there's a quarter-inch drill that's
Yeah.
cutting through the metal, these sorts of systems will actually detect 5-10% changes. These slight
In
changes are
speeds
indications that the tool's getting
or load.
dull and it needs to be corrected. Yeah.
I see.
So,
I
yeah.
mean, that makes so much sense. And you'll be able to know when, probably nearing the need to change maybe a tool head or sharpen or something like that. I'm obviously using a layman's understanding here,
Yeah.
but basically you're getting to monitor and control those things with more and more refined tools, more and more refined sensor capabilities.
Absolutely, and that's one of the huge things in the last 10 years is building out these sensor capabilities and being able to monitor tools in this way. Another area that so these are some of the problems that we deal with in
Hmm.
some of these sensors. Another thing that we've seen development with is with connectivity and connected machinery. We can keep track of what tools are in each machine and things like that. These are things that have happened in the last 10 years. They don't really lead towards the AI that's in the industry today. But one of the things that we're seeing is utilizing something like machine vision, right? So there's a huge use of machine vision to bring in a customer's print file.
Hmm.
Oftentimes these print files are transferred as PDF files. Sometimes they're transferred as PMI data through the CAD model where it's
Hmm.
digitized already. But taking these existing PDF files, scanning the prints themselves, and then having the computer do the building out all the control plans,
Hmm.
building out all the first article inspection document, the in-process document, building out these documents, and then also adding the data directly to a database so that whenever you're doing quality inspection on parts, this information is being loaded directly into your database. You can make a measurement of part. That measurement gets saved with the part, and you'll have a historical record of it. So the area of AI that really helps with that is
Yeah.
one thing, getting the data into the computer, which is something that took a lot of time to do, and then
Yeah.
also helping with increasing the ability of companies to get the data to the computer, saving the information. Usually, that's utilizing a system in a computer. There are ways of utilizing AI to scan documents and to scan data, and to also speed up the ability for people to integrate these systems by automating some of the workflow of just regular programming.
Yeah, I mean, I could imagine this data is coming to you in all different types of formats, and that is one thing that generative AI and also vision AI are pretty good at is taking a generalized approach and being able to, for lack of a better description, interpret what it's seeing and fill in the blanks in the proper spot. So it can look at it like
Right.
if you want to store it in a database, it can make sure it's mapping without knowing too much about what you're doing. It can map really well in a way that a narrower model might have some trouble with.
Right. Yeah. So that's an area that people save quite a bit of time in their workflow, and
Yeah.
getting data to the correct location. It can be sometimes harder than you'd think.
Yeah.
Training people to use these UIs and to navigate the information
Yeah.
isn't always the
It's
easiest thing
cumbersome.
and most straightforward.
Yeah.
Yeah. So any way that you can build a digital workflow to reduce the amount of work that somebody needs to do, it's always helpful.
This is an area that I feel like is almost good fit across the board, whether no matter what industry you're in. I think annoying forms and having to copy and paste really manual data from one thing to another in a different format. I'm really looking forward to the day when that's all in the past, because I feel like it's already gone pretty far. I mean, I use AI many times to just take a junky file and make streamline it and turn it into something that's really, really rich and able to be generalized. So it has, turn it into like a CSV or something like that, or even a database. And I just think every industry is benefiting from that right away.
Absolutely. One example, so with this free software, in my current role, I do a ton of work with the API and integrating other systems with Esprit and, building out automated CAM programming workflows. And one of the things that I found AI to be really helpful with is parsing data files, like tool data files and
Yeah.
stuff like that, and converting that data file into an object, or like
Yeah.
with properties that can be embedded into a VB.NET or C# program or something like
Yeah.
that. So
Yeah.
it's really cool in that way
So
to be
nice.
able to do that. Yeah, absolutely. Yeah, I mean, these are all kind of really interesting areas. The area that I'm working on personally, and we're seeing a huge amount of development with, is
Mm-hmm.
trying to automate CAD files.
Yeah.
So automate the processing of CAD files to CAM programming. So it's a really interesting field, evaluating the CAD file, and then converting it. So it's definitely
Well,
interesting.
I want to spend a little bit of time on this one because I think this is such a cool area. I also think that if I look at other industries, I have friends that work in architecture that actually work for companies like Adobe or Autodesk. And there is people trying to solve parts of that problem all along from design to actual manufacturing. And they're definitely injecting AI in creative ways all along the process. It certainly is very early days, as far as I can tell, in terms of the value that we're getting out of it, but it's definitely accelerating. I don't know if you would agree, and maybe I'll touch on a
Yeah.
few examples, but what's your general sense of how this is progressing?
It's progressing fairly quickly. I think in the CAM industry, it's been around to some extent for 20 years, right?
Yeah,
Our print file, and then taking it, analyzing the print file, and generating a CAM program very quickly that way.
like an
Or
optimal toolpath from that is, yeah, essentially.
yeah, just to try to get the CAM program, the
Yeah.
baseline of it built quickly. The other area is building out these systems where you have a part that you make. Let's say you make screws, and you make 5 different types of screws, but they're all different shapes and sizes. You
Hmm.
you can we've seen a lot of these systems where people just input a couple metrics, and they can quickly produce the complete program for a screw like that. Every CAM company on the market has dabbled to an extent in this area, and it's been taken very seriously in the last year. I think probably the catalyst was AI, obviously, but there's a company called Cloud and C that's doing
Mm.
great work and automating milling
Hmm.
toolpath. They've really created an awesome system that works with a ton of different types of parts, and figured out how to determine the cutting path that's necessary on CAD files. It's really impressive stuff. So if you ever get a chance, check out their website. And in my project that I'm working on, we work with engineering departments and companies, and we are really focused on a different type of machine than Cloud NC. We do mill turn machines, and we do some milling machines
And
processes. But
just
yeah.
for our listeners, a mill turn machine, is that sort of like more or less a rotating cutting tool?
Yeah, a lathe is a rotating part, and then a mill is a rotating cutting tool, and then a mill turn is a lathe and a mill kind of built into one
Combined.
machine.
Okay. Yeah.
Yeah, yeah,
Cool.
with varying degrees of capability. And
Yeah.
so, the algorithms that I work on, we work with specific customers and take a wide array of their engineering workflow. They have a lot of regular parts, and we work with the fact that they make a lot of very relatively consistent parts, maybe with a bunch of features, and we're able to identify all the unique features and apply the toolpath like they predict. Another area within Hexagon is some people have developed a method for you can train the AI system on legacy cut path and cut data from your machine shop. And then whenever you're building a process, the AI will kind of look through the process that you're building and then try to pick the correct toolpath as you're working. So it's really like an assisted AI system. But every AI system in the CAM industry today is an assisted is an assistant, right?
Yeah.
There's no like load the CAD file. Like 3D
Walk away.
printing is 3D printing so fast, right?
Yeah.
You load a CAD file in, you're basically set to jet. In the area of machining, it's not quite there at the moment.
Yeah. I mean, you've got so many more variables, I imagine, to deal with than squirting some material out at the end of a tube and moving a head around.
Yeah. And not to say that that's not complicated in its own right, but
we can oversimplify.
The variables are significantly different. One of the big things is that there's millions of cutting tools on the market.
Yeah.
Maybe only a few types, but all shapes and sizes with different fluid angles and stuff like that. And integrating the cutting tool database and system into the manufacturing workflow and in the CAM system, that's something that's really been taking off with these companies like Tools United and Sandvik now owning 2 CAM systems, these big tooling vendors. And these tooling vendors are integrating their tooling databases with the CAM environment to increase the ability for programmers to source tools quickly. And that's kind of a neat thing because it can take, I mean, if 12 tools for a process I need to go online and find them. The internet saves me a lot of time because I can, find them quickly, but it takes a lot of time to find tools.
Right.
But one of the funny things that I found as a CAM programmer is I can actually load the tool description in the chat GPT that I'd like to find.
Right.
Run a query in ChatGPT, and it will identify a close tool to what it is that I'm searching for. And that's really fascinating.
I was just going to ask you if that was possible. So it sounds like you're already doing that. One of the things that showed up when talking to my architecture friends is they're just like struggle with the thing called takeoffs. I don't know if you've ever heard that term before, but it's basically like if you have, say a room and you want to determine all cuts that are going to happen in a room, they have to manually click on like little bits here and there to get that information. I am assuming you have sort of a similar type of problem, which is you've got all these toolpaths that may have been defined, CAM application you've picked. I'm assuming diagnosing that and walking through that toolpath and troubleshooting it is sort of a manual process, I'm assuming. And I guess where I'm heading is, what are areas that you see sort of a generative AI, kind of like your application of ChatGPT, where it can help you narrow down problems and identify, better alternatives that maybe isn't so heavily relying on finding, creating the optimal toolpath, but more just helping you rifle through all that information.
Yeah. So like we were talking about, programs might have 2 million, 3 million lines of code in it. And one line of code can ruin a year for somebody, right? Yeah. Because if you crash a $500,000 machine, you basically might not sleep for 3 weeks. So, the thing about it is there are all these systems integrated within the manufacturing environment to try to reduce that risk. And then also try to identify part error because, sometimes we make parts that are expensive, right? So like if you think about it, huge crankshafts have to be machined for freight ships, right?
Generators or whatever,
or power generators or something like that. You have very, very expensive parts. You have parts made out of rare alloys that are very expensive. I worked in a shop that only focused on refractory metals. These are very expensive, hard to machine materials. So taking the time to build an engineering workflow that takes into account all of the risks that can happen. That's something that's very possible today. It's something a lot of people are doing today, and there are a lot of systems that take into consideration these risks, and it's only getting better. But there's this hot term on the market. I heard the CEO of Siemens talking about digital twins. But digital twins, we talk about it at Hexagon. Everybody says, okay, these digital twins, how do we digitize?
Are you saying digital twins?
Digital twin environments, right?
Yeah. Okay, I have heard this term. Okay, go ahead.
Yeah, so that concept is how do you take the real world, the physics that apply to the world that we live in, and then embed those into a computer environment and then utilize the information that's being handled, and that would be handled in the real world in the computer. And so let's go to the CAM programming workflow.
Hmm.
There's kind of these inherent risks when we program in the CAM environment. A lot of CAM softwares today don't keep track of the tool load that's in cut.
Yeah.
There are these add-in softwares that are doing that, like NC Simul, SenseNC, I think does it. Vericut might do it. But maintaining data on the tool load can be critical.
Yeah.
So keeping track of that information before it gets to the machine, that way you don't get to a cut or a corner that's critical in the machine
And you
and the tool
can't make it.
breaks.
Yeah, you can't make
Yeah,
it.
yeah, the tool breaks too quickly. So keeping track of that information, getting that before it gets to the CNC machine is really important. One thing that I've heard of is with this spindle load monitoring systems. If you have a really fine-tuned spindle load monitoring system, you might be able to have a sense of the tool load that should cut on the machine before it gets to the machine. So you might be
Hmm.
able to preventively keep the machine from breaking. Another area that this isn't AI, but sensors work really well is probe sensors. But also, people are starting not just using Renishaw probes or Bloom probes. People are putting actual scanning devices into their CNC machines. So taking a part scanning device, bringing it into your CNC machine, you can scan the part within the CNC machine using kind of point cloud data and 3D scans, which I think Hexagon has one that they put onto their CMMs. I think they can actually
And is
integrate with
that
a
just a
CNC too.
camera that, or like maybe it has two cameras and they
It's a
call it a scanner?
3D scanner, precision 3D scanner.
Okay.
It takes the data and ports it into the machine, right, into a measuring system, and the
Yeah.
measuring system will tell the machine if something needs to be recut.
Well,
If you can keep the part in the machine and measure it correctly, you can save yourself a lot of time by
yeah.
having to reinstall it and recalibrate it. And some parts are almost impossible to recalibrate after you've taken them out of the machine. Um,
Well, you maybe had it here. Maybe I'm jumping ahead of you, but it seems like a perfect opportunity for simulation. I know that they have 3D models of the parts, and I probably can simulate that stuff to just figure out before they're actually having to test it on expensive materials. What is the state of that, and how does that relate to some of the improvements in AI, but also in sensors and tooling?
Yeah, so keeping track, in a computer's mathematically based system that people in the last, well, we've always used computers to simulate physics, right?
Yeah.
That's really been the backbone of the computer industry is how do we use these computing devices to determine the
To
physics of
calculate.
yeah, right? Because that's what they do best. And within the CAM programming environment, there aren't a lot of finite element analysis algorithms that are inherently built into the CAM system because what you'll find is you'll cut apart, everything goes perfectly, but the
Yeah.
part itself has internal stress, a strain that's relieved by the cut, but it bends it the wrong way or something like that. So
Mm.
there's not that right now today in the CAM environment predicting these sorts of loads, but there are conversations about it, and
Is that because you were talking about digitizing and having a digital twin? Is that because the digital twin right now of a part or a raw material that you're going to turn into a part is pretty poor relative to its real physical world partner? Or what's the major reason we, don't have really accurate simulators to be able to predict the outcomes of the part or many parts?
computationally, I guess relatively intensive.
Prohibitive.
Yeah, and then you're handling tons of variables, right?
Yeah.
So we're not just talking about taking a EDM or like a different type of machining process and just magically removing material from these parts. We're talking about applying
Hmm.
extreme forces to the parts
Yeah.
that can, sometimes change the properties. And something that a human does really well
Hmm.
that a computer doesn't do as good of a job, but it's gotten so much better with image processing systems.
Sure.
Because a human can look at something and process space on whatever it might be extremely quickly.
Yeah.
So I always say,
We can sense stresses that
and
the machine would
material,
really
yeah.
have a hard time picking up. Yeah. I
Yeah,
can see
so
that.
that's where you have your manufacturing engineers or CNC programmers or machinists, master machinists. They'll look at something, and this happens all the time, right? You'll have all these great ideas through we need to make this part this way, and it has to be made like this, and it gets to the machinist. The print gets to the machinist, and the machinist will say, "Well, you're not going to do that." Right, and that's where you have that knowledge. You have that, we are everybody in every field, we're all building this great library of knowledge in our brains.
Yeah.
And when we see things, we can just very quickly identify the risk a lot of
Yeah.
times. And that's why we have design for manufacturing meeting, DFMEAs, and design for manufacturing, design for elements and effects analysis, where we talk to the production teams, and we try to identify very quickly if there's risk. Something that often happens is, in the US, we have all these contract machine shops and manufacturers, but and then you have the design team, right? So you have all the
Hmm.
job shops, and then design teams are like a bridge apart, or maybe 1,000 miles away from whoever's making their parts, or
Right.
maybe 10 miles away or something.
Yeah.
But keeping constant communication with the mechanical engineers whenever you're a subject matter expert is always
Yeah.
important.
Yeah.
I don't even remember what question you asked me, but
No, no,
I just got
you were
into
heading
that.
down the right direction. And I'll just sort of echo back what I feel like we're landing on, and that is there's nothing that substitutes at the moment the human intuition based on their experience when it comes to manufacturing at this level. Obviously, sensors and inputs, visual cues, data, all of that stuff is extremely helpful and developing, machinist's intuition. But
Yeah.
we really haven't been able to digitize that experience and make it so we have, high quality decision making happening in the simulation environment.
Yeah. So, this is a fascinating topic. Back when the cotton gin was created, there's all this worry that the world was going to be filled with machines and there weren't going to be any people because the machines would do everything, right?
Yeah.
I remember reading about, politicians worrying about this.
Yeah.
I mean, there is concern. We're
Yeah.
getting closer and closer to that prospect,
Sure.
with the development of humanoid robots. There aren't any humanoids on the market that are machinists today, but is that something that's going to go that direction? All these humanoids can do parkour, but they can't run a CNC machine. I don't know why we're focused on humanoids doing parkour, but it's kind of funny. But the thing about it, this is reiterated everywhere.
Mm.
When you spend time doing something, you become good at it, right?
Hmm.
And one of the things about machining is it takes years to learn.
Mm.
You're not gonna bring someone in and they're gonna be an expert in a month, 2 months, half a year. It might be years upon years upon years of learning a trade. And manufacturing, we're constantly dealing with things. We deal with the world that we can't see. Of course we can see the parts, but we sell in precision machining precision, and
Yeah.
precision's not visible by the human eye.
Right.
We never dealt with anything in precision that's visible with the human eye.
Yeah.
You're using systems to keep track
Yeah.
of. Some precision is not so precise and then is visible by a human eye, but that's error. And we
That's a
do
really
see
good
those
point.
things.
So you're
Um,
already at a scale that humans cannot perceive because it's
yeah,
precision.
it is. Yeah, we're dealing with 0.0001 inches, 1 micron, 0.001 millimeters, and precision. And that's machining precision. There's higher levels of precision in
Hmm.
manufacturing, but that's partially, and there's higher levels of precision in machining too, to some regard with calibrations.
Yeah.
But the thing about it is we're dealing with high levels of precision that are not really visible to the human eye. And it takes a lot of intuition by people to really be able to understand the complexity of a problem that you run into. When you're a machinist, you're a very high level machinist,
Hmm.
you're running, let's say you're running a $50,000 part. Let's say you one or two of these parts goes through your cell a day,
Yeah.
right? And it takes a lot of calibration and a lot of times with these parts to make sure that the machine's calibrated. Often the part like that's big. Often, sometimes we deal with cutting features on parts that are so expensive where you have to get it right the first time, the cut.
Yeah.
And I'm talking about 0.0001 or 2
Hmm.
inches, 2/10 cut on a $50,000 part. You can't make a wrong cut. When you're leading up to this is a process that can take a half hour sometimes to put together because you have to prepare the tooling. Sometimes the tooling wears down through the cut. You're
Hmm.
dealing with physics
Really,
constraints.
really hard
Um,
materials or really small
real,
parts.
really hard materials. Are you dealing with making tons of really small parts?
Hmm.
Keeping these machines calibrated takes a lot of effort and
Hmm.
time. And a lot of the problems that when you're a really high level machinist, you're dealing with problems that are, a lot of huge amount of intuition.
Hmm.
A machine that has 50 tools on it. Every tool needs to be calibrated. You can't see the tool. You can only measure the part.
Hmm.
The tools are expanding and contracting throughout the day
Yeah.
and changing more than the tolerance your parts allow. So you
Wow.
have to keep track of that.
Hmm.
One part, your tool's out of calibration. You have to recalibrate that tool and get it right before you cut the next part. But you
Yeah.
can sometimes only know if the tool's calibrated by cutting a part. So you're kind of, yeah. Is it possible for computer systems to do this stuff? And I mean, we see around the world that oftentimes it is.
Hmm.
Not with everything, but with a
Yeah.
lot of things. And that computer is really helping in this way. Now, this gets us to an ethical problem that
Hmm.
we've created. If you create enough humanoid robots that are able to go into manufacturing, and we end up solving all these things.
Hmm.
What do we do? How much time do we have on the day? I only have so much time that I can spend reading forums on Reddit and looking at cat videos. I get bored after a couple cat videos. So and then I'm not really an athlete.
Oh, you're an athlete.
Yeah, I enjoy skiing. I enjoy walking, and I enjoy golfing, but I'm not the best at those things.
Okay.
But
If you're trying to sell me on that we need to still keep working and not going golfing and skiing, you're not selling
No,
me
I'm
there.
not selling you on that.
I'm into that.
No, I'm not selling you on that because
You're speaking my
I think,
language.
yeah, what I'm trying to say is that work gives us
Hmm.
a lot of purpose in life as people.
Definitely.
We get a
Yeah.
huge amount of purpose from what we do.
Yeah.
Now, there's this company, Seiko Watches, I think is the company
Hmm.
that made this amazing watch, right? Clock building time clocks and stuff for years was always precision work, right?
Yeah.
For
Yeah.
mechanical clocks. It's always a huge thing. Now, Seiko was, I think, one of the first companies to come out with a clock that was not mechanical. And
What does that
yeah,
mean?
it
Not mechanical.
not mechanical. I think it used, I'm not a physicist. I used some sort of property of,
Quartz.
yeah, to quartz watch. It's a quartz watch, right?
Oh, it's a quartz
So
watch. Yeah. So they were
yeah,
using the
yeah.
I think it's like something where it's predictable how often a piece of quartz will like emit electron or something, like, I don't know.
Yeah. So the quartz watch, it's the most precise
Okay.
watch. It was the most
Yeah.
precise watch. So then,
Not mechanical as in not wind up,
yeah, after they made the quartz watch, everyone started buying these quartz watches, and mechanical
Yeah.
watches was seeing the end. But watchmaking was always a fine craft. Well, anyway, I think they laid off a lot of watchmakers, right?
Yeah.
But I think in the end, Seiko brought in a bunch of watchmakers to
Hmm.
make more mechanical watches. And I think this concept, right, of appreciating the Amish, appreciating appreciating the limit of technology to some extent,
Yeah.
is something that's very important in life and very much makes us human, and it very much makes life, and
Hmm.
enjoyable. Not everything needs to be the most precise. Not everything needs to be done by robots or anything like that. And in the end, it's going to be really hard if you take a whole industry and you devote it to robotics, and automation, and have the
Hmm.
entire industry, lights out, facilities that are completely lights out, programming that's all done
Yeah.
by computer. And this is where we're going.
Yeah.
And this is the possibility that is there. Well, what happens to these young, passionate kids that want to like
Hmm.
solving problems or want to get into engineering? I love
Yeah.
working on the machine and learning how to run CNC machines. It
Yeah.
was stressful. It's one of the hardest things I've ever done, but But in the end of the day, mastering something that I couldn't do before was extremely enjoyable. We have to think about the next generations that come and realize that as we design the world, we have to consider a way of allowing them to have these enjoyable problems and challenges in life that are going to be extraordinarily rewarding for them. And after solving these problems, they're going to be so proud of themselves. They're going to understand things at a whole nother level. I mean, if
Yeah.
I asked ChatGPT to program something for me and I embed it in my program on Visual Studio, I don't quite understand the logic structure as well as if I wrote it myself.
Yeah.
Right.
Well, so
And
that's,
that's
yeah.
the
Yep.
that's the problem that I think when you ask about
Hmm.
this human level, I think that's important for us to think about. Absolutely.
Yeah, I really like that thought. And you brought in a couple of good references there. You mentioned Amish, for example, which they, have a commitment to a certain period of time and they're sticking to it, and
Yeah.
is
Yeah.
spot in technology. And one of the things I wonder, and I think your examples on some of the challenges of simulating physics and some of the limitations there, absolutely, I think we're going to get better at this stuff at a really rapid rate, especially in the next 20, 30, 50 years. What I think might surprise people is how many problems are left over that are unsolved, and that our new tooling will sort of open the door to unlocking some of those challenges. But I think we're going to have a whole trove of unsolved problems
Yeah. Uh,
we'll get
it,
some leg
there.
up. But I think
Yeah.
there's going to be a big bag, and we're a little bit too confident with the technology we've built to say that we're
Yeah.
going to move through these problems so quickly. And I agree
Well.
that the manufacturing industry is one that you've seen tremendous automation. And
Mhm.
I think we had Peter Haas on just a few weeks ago, and he was just talking a little bit about the automation rate of manufacturing. It's been exponential. And so I do think that trend will continue, I imagine, but we're still going to need experts. We're still going to need people to think critically about problems, even if there are, the equivalent of a TI-86 on
Yeah.
steroids.
Okay. So I could share some philosophical ideas
Yeah,
if you're
yeah.
interested,
Please, yeah.
because I think that's what this is about. So we're going to take my professional understanding of the world and we're going to put it over here, and we're going to
Okay,
step
great.
into my reading side and my enjoyment of playing with ideas. So, okay, so let's just think about this. So you're in a society, you're in a world that exists in this time frame, right? And, we have a certain amount of capability and understanding of technology. Now we can think about it in multiple ways. We can think about it as, oh, this could come to an end, right?
Mm,
Limitations of technology. We can think about it as, what happens if this goes on forever? We
mm-hmm,
went from zero point 0.1 inches of precision in
mm-hmm.
metal cutting and any really precision engineering in 1776 with the boring of cannons. Zero point 0.1 inches. Now we're like infinitesimally small levels of tolerance and capability of these systems. Now,
What would you
as we
say? I don't mean
yeah.
to ask you this off the top of your head. So if you don't know, that's fine without having to Google it. What do you think what's the highest rate of precision that we're probably able to tackle right now as humankind
Yeah, so probably something like,
in manufacturing, rather?
yeah, like the ASML semiconductors are cutting nanometers, I think.
Wow.
And this is in photolithography
Yeah.
processing
Right.
of CPUs and computers, right?
Yeah.
And when you get so small of operating processes, like we all talk, everyone knows the Moore's law, right? We all know the Moore's law. So when you
Sure.
talk about the Moore's law, this compounding efficiency of CPUs that we've seen, technological advances. And what has happened is the Moore's law doesn't really work anymore. And the reason that, even though we've seen a huge amount of improvements in computer processing capabilities, is that the channels that we're cutting are only so many atoms across, and they're failing due to the amount of atoms, like under
Yes.
100,
Yeah.
atoms
Exactly.
across,
Yeah.
right? So we've
Running out
reached
of
this,
space.
running out of what our current systems can do today, right? So
Yeah.
yeah. So anyway, we get it. Yeah, that's I think that's one of the smallest. Now there are other degrees of precision that exist, right? In terms of like calculating GPS systems and how precise they're becoming and stuff
Right.
like that. But anyway, there are various levels of precision, and launching a rocket and having it make its way all the way to Mars. That's a very unique level of precision that's happened to
Yeah.
get all
I
those moving
guess
parts.
so.
Yeah,
Just to say back to you a little bit, there's obviously we have ever increasing ability to calculate more and more precise numbers, but
yeah.
we've hit some physical limits when it comes to physical manufacturing. Is that a fair
I mean,
assessment?
yeah. I mean, there are limits. There are some limits to
We're
physical
slowing down. Let's put
manufacturing.
it that way.
Maybe, yeah, maybe,
Maybe.
yeah. We'll see. I am not one to know the answer to that.
Okay, fair.
Yeah, yeah, because there's if you think about it, if I count as fast as I can, right? Like 1, 2, 3, 4, 5, as fast as I can. It takes about like
Yeah,
75 years to get to 8 billion,
yeah.
which is about the amount of people in the world. So to think that I could have any clue as to what everybody else on this planet is doing at this moment in time is just ridiculous.
Yeah,
Because there's so much technology people are working on right now
yeah.
that's going to blow our minds, and we're going to say, "Oh my gosh, I can't believe that happened. Why was I not on that train?" No, I'm just kidding. But that's the
Yeah.
so yeah. Anyway, so we get into this world of, like you said, dialing into a certain timeline, right? Of understanding of the universe. I mean, that's possible. But I read all these fun books. I read like The Hitchhiker's Guide to the Galaxy recently. Read the
Uh-huh.
Ready Player One series, which I thought was a lot of fun.
Yeah.
I read Plato's Republic recently, which was kind of mind blowing. Some other philosophical readings from the ancients, and I enjoy reading a lot. And I last weekend I read a book on precision engineering, so I'm a little bit hyped about precision. But I've been working on it for 10
Well,
years,
then
so
I
it's,
got you at the
it's
right
exciting.
time.
You did, yeah, yeah. I saw this one. I said I've got to read it before I talk to James, because it's good. I'm just going to be so hyped up about it. I think when we get into the world of philosophy, and when technologically we get to this point of dealing with atoms and possibly manipulate atoms and build things, you might see these, and in sci-fi we always talk about these 3D printers, 3D printing anything, right?
Mm-hmm.
That's all great. Now, one of the ideas that's more religious that I've thought about a lot is, life, continuation of life, and what that looks like, eternal life, and things like that. And how does technology fit into that world, right, of eternity? And when you get into the thought processing of it, you start to think, well, let's say I'm a fish for 500 times, and in all these different species so many times I get bored of it. Could I, if I get reborn or get to choose what I get to become or something, could I create a universe? Could I design a whole universe?
Mm.
Could I design conscious? Could you reach a point of understanding of life that could design consciousness at some point, a system of consciousness that grows, not just one but multiple? And yeah, in the world of AI, we see image creation happening so quickly. Are there life forms that can do that with atoms, physical systems? Develop not just two-dimensional images, but three-dimensional objects that we can hold, 3D printing a car or something like that.
Mm-hmm.
The world of AI, I talked to chat with it, and I discussed these concepts with it. And I've had some pretty profound conversations just sitting down talking to ChatGPT for hours on end, and they're fun, and I've developed some interesting concepts and ideas. And I think what AI has kind of done for me personally is it's opened the door to these concepts of technology that I didn't ever think could ever be possible. And
Like
then
what's an
realizing,
example?
like, the image, rapid image generation is,
Mm-hmm.
is is insane, and video generation.
Mm-hmm.
If you could do that with an actual world and
Mm-hmm.
live inside of it, designing
Yeah.
a, let's say let's say you design a universe, right? Like Ready Player One universe or something that's
Mm-hmm.
designed for introducing people to consciousness, right? Would you fill that universe with movies? Yeah, I think I would. Would you put books in it? I think I'd put books in it. Would you put schools in it? Yeah, I think schools are pretty cool. We give people these opportunities to learn. right? And you give these conscious minds opportunities to learn, explore, and find their interests. And then you send them off and you tell them to go explore. Well, that's just very suspicious. But past the point of belief and these kind of far-fetched ideas, I think it's fascinating the ideas that AI presents and enables us to think about past the idea of trying to automate the world. When we get too far into AI and designing these AI systems, it's good to understand how to do things. I think,
Yeah.
like I said,
Yeah.
learning how to do something was more important to me than just being able to do it as an engineer. And I think if we think about life as we go through life, learning how to do something, giving kids the opportunity to learn, giving young engineers opportunities to start a field in a really hard to do place and figure their way through it. I think all these things are really important for the development of life. And I think
Hmm.
as we evolve societally, as a species, as life, because life is so critical. Without life, without consciousness of life, the universe is empty. It's just a void, right? It's
Mm.
just a bunch of rocks floating around. So life is so critical. And as life continues to evolve, we always have to, in our technology and our ability to adjust the world around us, we have to continue to think about how we give ourselves these chances in the world to continue to learn, challenge ourselves,
Yeah.
solve problems.
Yeah.
You don't. I think if you gave everybody in the world a 3D printer that could 3D print whatever the heck they wanted, whatever car, some people would probably keep it forever and never go back. You'd say, I just want to 3D print a Millennium Falcon as many times as I can. But I think some people would say, that's fun,
Pretty
but
empty.
it's empty. Yeah. I want
Yeah.
to learn how to make this
Yeah.
too. Yeah. You can only play a game for so long before it becomes
It
a
gets
little bit
boring.
boring. Yeah.
Yeah.
So, yeah.
I think that's such a really good point. And, it'll be interesting to see what sort of time scale that even becomes a problem. But it's certainly we're catching glimpses of that kind of potential reality. And so I think that's a really great thing to reflect on. We only have probably just a couple more minutes. And so why don't we just pause for a second and see if there's, anything else along the lines of see if there's anything else that you feel like is really important to share, given your experience in manufacturing and also in education, where you see signs of hope for those trends to continue to teach, continue to learn, are going to continue for a long time.
Yeah, I think if humanity's survived the last 100 years of industrialization and where we are, and some people might say we haven't, but I'm just kidding. I- there is a lot of I see people interacting. I see movies that are so inspiring, and
Hmm.
you still see have this sense of connection to all these different things. I think it's really amazing. And I think one of the things that it's actually uniquely amazing, I'll go back to precision machining.
Uh-huh.
Engineering is often thought of as kind of an off branch, was often thought of as kind of like this edgy thing for people to do.
Yeah.
Antisocial. I have found the complete opposite as an
Yeah.
engineer.
Totally.
I the amount of care, the amount of joy that being an engineer has brought into
Yeah.
my life
Hmm.
has been amazing. And the people that I've met and the times we spent together solving the most, silly things,
Hmm.
but feeling like we're really helping people, feeling like we're really, doing something that's fun. We're connecting
Hmm.
through the problems that we're solving, and I think we'll continue to see that with this AI revolution and these systems that we're developing. We'll continue to see people finding ways to connect, finding ways to share their experiences with others. It's amazing to see biologists using AI that learn how to speak with animals more easily. It's amazing, it's amazing to see people in engineering connecting very quickly on the internet, sharing ideas. A whole industry blossoming because of connectivity. It's just really fascinating. And you see, look around the world, precision engineering was a European and American thing for so many years now.
That's
Every
everywhere.
country in the
Yeah.
world's able to produce really high tolerance parts now.
Yeah.
That's amazing.
Yeah.
These are all things that really, it's hard sometimes for us to perceive the world, and because we're always trying to connect the bigger picture to our current reality and
Hmm.
stuff like that. It's really amazing what we're seeing, and I think we'll continue to see technological development, we'll continue to see humanity develop and become
Yeah.
more connected. And I think it's amazing. Yeah.
Yeah. And I think not just having a 3D printer to give me anything I want machine will really benefit us, because I do agree that being challenged, facing a problem that you can solve with your community is something that is really exciting and helps you grow as a person and as a community. So I'm also hopeful for that future. And I just want to say thank you for talking with me. This has been really fun. And John, thank you for joining the Smolder podcast.
Yeah, thanks, James. Really appreciate it. It was a lot of fun. And I'm going to have to come see you up in Portland sometime soon.
Heck yeah.